Okay, next up is my colleague Peter Loscher from ISC. Peter's going to be talking about a new service that we have to offer. I'll add that there's a significant public benefit element to this. It's not just a product plug. But I'll let Peter tell you his story.
Okay, so many of you probably know me from my other hats, including operating f.rootservers.net. But I'm here to talk about our new service called SNS at ISC. I'll skip over the overview. But as some of you may or may not know, we have a history of doing DNS operations. As I said before, we do operate one of the 13 root servers. We've operated f.rootservers.net since 1994. We've also operated a small secondary service, which is anycasted in the San Francisco Bay Area since about 1996. Or, yeah, 1996, and now we house over 700 plus zones, all that being public benefit. We've also helped operate the AS112 project, which has now been handed over to a sister organization, DNSOARC, and we also operate an AS112 server. For those of you who don't know what that is the servers that handle all the RFC 1918 address space PTR lookups. We are also a proud supporter of OARC, and we also participate in the annual Day in the Life, where you take a 48-hour snapshot of DNS data and submit it for analysis from folks like CADA and so forth. And last but not least, we manage this little software package called Bind. Some of you might actually run it. So why are we doing this? I mean, obviously there are other outsourcing DNS providers out there, and I'm not going to sit here and say why they all suck, because they all provide value into the market. We hope that we have a similar vein. One reason is because we do have support customers for our Bind and DHCP software packages, and they've offered us from time to time, can you secondary our zones for us? And we always say no, because all of our bandwidth and so forth is all donated, and we can't monetize that. And also, we wanted to take NSCXT global because we have this little Anycast network in the Bay Area, and it says, well, wouldn't it be cool to make it global like we kind of have done with Effort? We also wanted additional cases for bind development, like with larger zones, larger sign zones, where we can have bind developers have direct access to the gear. So if we ever come up against a problem with bind, we have a direct access to the bind developers, and it makes it quicker for them to get to the problem. So it helps accelerate bind development. I will let history speak for itself about our record. So we've come up with two versions of SNS at ISC, one for the public benefit, one for commercial. So SNS-PB will be basically targeted for public benefit nonprofits, 501c3 organizations in the US, NGOs, and so forth. So we're going to give them the same type of service as we're going to give to commercial customers, and we're going to use our existing F-Root backbone or F-Root network to serve these servers. Does this mean we're going to actually put SNS-PB servers at every place we have an F-Root node? No. SNS-PB servers are much more expensive than F-Root servers, especially because of the memory requirements. We have a lot of CCTLDs and so forth that we have on public benefit, and which requires a lot more memory, and also there are the bandwidth requirements that we have that would exceed a lot of our global or a lot of our local nodes, say in South Asia or South America or so forth. So what we're trying to do is we're trying to target our big effort nodes where we have a lot of transit, where we've had partners like Hurricane Electric, EasyNet, and so forth, where we have the bandwidth to actually handle all that traffic. So on the other hand, we have SNS-COM, which basically handles everybody else. So we've been fortunate to have other partners where we're on their commercial backbone, and so we're doing it where it's a completely separate network from our AS1280 3557. So what we're trying to do is target the Power DNS user that wants a global presence. So this is the public benefit architecture. As you can see, we're anycasting a single /24 and also a /48, where we have it broken down by region, where they will all announce that global space, and then they'll also announce a regional space for, in case of some reason, someone wants just Asia instead of having a global address. They just want an address in Asia or an address in Europe or someplace like that. So we have 2 servers at each location, and we will expand as need be if the traffic dictates. So these are all happily donated by a large server vendor, and actually they're all Itaniums, so that should give you a hint. So SNS-COM is slightly different. We have each provider, we're using their IP space. So in the guise of our president, he calls it green networking because we are not taking out more IP space for it. So so we're actually doing per provider anycast. So provider 1 is NS1, provider 2 is NS2, and so forth. So the zone transfers go into our distribution master. We then send the notifies out to the individual servers. And obviously when queries come into provider A, it hits the closest server to provider A. So if you're in Europe, you go in through Amsterdam, you hit a server in Paris. If you're in New York, you hit a server in Ashburn, and so forth. And obviously if a node goes down, like say the one in Paris, the traffic goes to the next closest one, which is in Ashburn. And then here's a brief display of how the zone transfers actually work. Customer notifies the distribution master. We pull the zone with TSIG. Once the distribution master gets it, it sends notifies out to the actual servers, which then pull from the distribution master. That's it. Any questions? Okay, Keith, next.
Okay, thank you, Peter.